This is a question from computer organization. In x equal to m plus n into O divided by p into q, how many one address instructions are required to evaluate it? So in one address instruction, an accumulator register is used to perform all the instructions. So we use accumulator register. That is the first point. Load and store operations are performed to fetch the values of operand from registers or memory to the accumulator and to store the value of accumulator to a memory location. So the instruction that is required to perform the following code is, since it is given as x equal to m plus n into O divided by p into q, we write it as follows. So the first operation would be to, following the rule of BODMAS, let's consider this bracket operation first. Now first operation is load n, that is, let's denote accumulator as AC. This accumulator will be loaded with the memory location of n. Now we multiply it with O, that is, in the accumulator what happens is the accumulator value will be multiplied with the memory location of O. Now we add it with M, that is, add M. So inside the accumulator the current value will be this multiplication result. This is n into O. This would be there in accumulator. This will be added with memory location of M. Now we need to save this value. So we are store the result as T. So to the memory location T, we are storing the value of accumulator. Now we need to again load the value P to the accumulator. That is, to the accumulator memory location P is loaded. Now we are multiplying it with Q. So to the accumulator, the current accumulator value is multiplied with memory location of Q. The next step would be dividing the whole result with T. So that is, with accumulator we are dividing AC by M of T, and finally we are storing the result. Store the result to memory location X, that is, memory location of X will contain the current accumulator value, which is the result of this expression. So let's count the number of instructions. 1, 2, 3, 4, 5, 6, 7, 8. So the correct answer is option C, 8.